So the last part is we're going to use the fact that we're going to say the mean is 50 for this data, and we're going to say that the standard deviation, sample standard deviation, was 4.8. So our first question is, what's the probability of getting less than 50? So we're going to draw a curve each time to represent what's going on here. So we're assuming it has a normal distribution with a value of 50 here. So that's our mean. And then we're going to have a bell-shaped curve like this, coming back down again. And I'm going to use this graph. I'm going to group it all together, and we'll just copy it for all the other ones. So we'll draw a vertical line here at 50, and I'm going to actually move that just a little bit. So let me actually ungroup that for right now, and I'll regroup it after I get everything. So I'm going to actually center that around that red thing. Okay, now I'll regroup it back together. Okay, so what we're doing here is we want less than 50, and I just saw that I've got one more problem. I need to move this 50 right to there. Okay, I think I'm ready now. So what we want to do is want to highlight what the area we're talking about. Well, less than 50 is going to be here. We don't actually have to use the chart for this because this is the mean. So the probability of getting x less than 50 is 0.5. Half the data is less than the mean, half the data is greater than the mean. Okay, the second one is more than 54. So let's grab this thing, move it over. So what we do is draw a vertical line. So let's write this down. We want more than 54. So what's the probability of us getting a data point more than 54? So here's 50. So let's draw a line. It doesn't have to be exact. We just need to know whether it's the right or left of the mean. So greater than 54 is going to be this area. Now, because this hashed-in area does not start at the middle, what we have to do is a subtraction process. So what we do is we find the area under this half of the curve. So that's everything. And then we find from the graph, from the chart, the area that is up to 54, because that's what the values do. So what we're going to do is we're going to find the area. I guess we'll use red. The red area is equal to the blue area minus the green area. So actually, let me use A. So they're all A's, but I have different colors, and hopefully you'll just understand. So when we have blue is the blue area, so we can use a little bit subscript V to stand for blue, and a little subscript R to stand for red, and we subtract the green area. So we take all this area and we subtract this area. That'll leave us the red area left over. So the blue area is just 0.5 because it's the half that's above the mean. The green area is a function of the z-score, 54. So this is a function of Z of the green, which is going to be 54. So the z-score is 54 minus the mean, which is 50, divided by the standard deviation, which is 4.8. So let's see what the z-score comes out to be from that calculation. Okay, so we have 54 minus 50 divided by 4.8. And so this is a function of z equals positive 0.83. So then you go to the table. So go over to the table. And we look for a z-score of 0.83. So here's z 0.56 coming down 0.81. So what do you say? We said it was 0.83. So there's 0.83, 0.297. So the green area is equal to 0.297. Make sure I read that right. 0.29. So I'm going right to 0.297. So the total area is going to be the red area, which is what I'm interested in, is going to be equal to the blue area, which is 0.50, minus the green area, which is 0.297. And so the red area is 0.5 minus 0.297, which is 0.203. So that's the answer. So the probability of getting x greater than 54 is equal to 0.203, or 20.3% probability. What I'm going to do is I'm going to insert the page right here so I can take this and clone it so we can have the table in easy view. Okay, so there we go. So the next one is less than 52. C is what's the probability of having x less than 52? So what we're going to do is we'll draw a line, vertical line representing 52. Here's 50, so let's put 52 about here. So what I'm looking for is less than 52. So that's going to be all the way from the lowest value up to 52, like that. So to find this, we're going to find the blue area, which is less than 50. And we're going to add that to the green area. So in this case, we add the two numbers together. So the area, the blue area, is going to be 0.5 because it's from the mean all the way to the left. The green area is going to be a function of the z-score associated with 52. So it's a function of z, and it's going to be 52 minus the mean divided by the standard deviation, which is 4.8. So if we do that calculation, we get that z is going to be 2 divided by 4.8, which is 0.42. So the green area, go to the table, we scroll down to 0.42, which is right here, 0.163. And so our total area, so our red area, which is the entire, is going to be equal to the blue area plus the green area, And the blue area is a half, 0.5. And the green area is 0.163. So I get 0.663. So what we can say is the probability that x is less than 52 is 0.663, or 66.3% chance that the number will be less than 52. Okay, D, between 47 and 49. So the probability that x is between 47 and 49. So let's draw two lines that represent 47 and 49. So I'm going to put 49 here, and I'm going to put 47 there. So this is 47, this is 49. So I'm looking for this area. So how are we going to find that? Well, because it's symmetric, I'm finding the area either to the right of the mean or to the left of the mean. So I can find it all the way to 47, so that's the blue area. And then I can also find it to 49, which is the green area. So again, what I'm looking for is the red area. So the red area is equal to the blue area minus the green area. Now the blue area is a function of the z-score associated with the left limit, which is 47. So I take 47, I subtract the mean, I divide by the standard deviation, which is 4.8. So the blue area is a function of the z-score, so you get -3 divided by 4.8, and I get -0.63, -0.63. Now, to find the area, we find the corresponding area for z positive because it's symmetric. So we'll go to our table, and we'll find 0.63 here is 0.236. So we put 0.236. So that's the blue area here. Then we do the green area. It's a function of the z-score associated with the green number, which is 49. So we take 49 minus 50 divided by 4.8. So the green area is a function of the z-score of -1 divided by 4.8, which is -1 divided by 4.8 is -0.21. But we use positive 0.21. So we go over here to 0.21 and we get 0.083. So my red area, which is what I'm trying to find, is the blue area minus the green area, 0.236 minus 0.083, and I get that to be 0.153. So the probability of getting a number between 47 and 49 is 0.153, or 15% probability of doing that. Okay, E. Again, copy the drawing. So E is looking for between 47 and 56. So what we'll do is, let's write that down. Probability, what is the probability of getting between 47 and 56? So let's draw lines associated with these two limits. So we draw a red line here, 47 and 56 is over here. And so what we're looking at is this total area between the two, including the mean value. So again, we have to break this in two parts. We have the one over here to the left, less than the mean, and we have one to the right of the mean. Let's go ahead and write those numbers in. So this one is 47, this is 56. So what we're looking for is the red area, and so it's going to be the green area plus the blue area. And in this case, we just have to add them together. So the green area is a function of the z-score, which the green area is uses the value 47, so we take 47 minus 50 divided by the standard deviation of 4.8. And the corresponding z-score is negative 3 divided by 4.8, which is negative 0.6. So the z-score is negative 0.63. So what we do, let's go back to the previous page here and look this up. So we have negative, we use the positive value 0.63, so you get 0.236. So the green area is equal to 0.236. The blue area is a function of the z-score associated with this side, which is 56, so we take 56. So the z-score is 56 minus the mean divided by the standard deviation. And if we calculate the z-score, the actual value is going to be 6 divided by 4.8, which is positive 1.25. So we go to the table, and we look down this column, 1.25, we get 0.394. So the red area, which is what we're trying to find, is the green area plus the blue area. So 0.236 plus 0.394 is 0.63. So the probability of getting a number between 47 and 56 is 0.63, or 63%. Okay, let's add another. Let's add a page. Copy this over here. And now we can do the next one, which is F. Between 52 and 59. Now, I'm going to give you similar. The first one will be exactly the same, but the other ones I'm going to change the numbers slightly, so you have to redo the calculations. I don't want you to just copy it down what I'm doing, but the principle will be correct, and they'll be in the right order. So I'll have some mercy on you. Okay, so 52 and 59. So let's draw vertical lines representing 52 and 59. So what we're looking for is the area underneath the curve between those two values. Again, we're taking the distance from here. We can't find it directly from here to here. We have to find the blue area, which is going to be from 50 all the way up to 59. And then we'll subtract the green area which is from 50 to 52. And that difference will give us the red area. So this is 52, this is 59. So we have to do a subtraction in this case. So what we're looking for is the red area. The red area is going to be the blue area minus the green area. Okay, so here we go. That's what we will do first, blue area. So the blue area is a function of the z-score associated with whatever the right-hand limit, which is 59. So it's going to be a function of the z-score, which is going to be 59 minus the mean, 50, divided by 4.8. And if you do the calculation, you get 9 divided by 4.8, which is 1.9. So we go to the table, and this column includes 1.9. It's right there, 1.9. We get 0.471. Okay, the green area is from the midpoint to the first part of our inequality. So that's going to be green. So the green area is a function of the z-score associated with 52. So we take 52 minus 50 divided by the standard deviation. So that z-score is 2 divided by 4.8, which is 0.42. So we go to the table. At 0.42, which we have to go down here to 0.42, it's 0.163. So our final answer, our red area, which is between 52 and 59, is going to be our blue area, which is 0.471. And then we subtract a green area, which is 0.163. 0.471 minus 0.163 is our red area. So we get 0.308. And so what we were looking for here was the probability that the value is going to be between 52 and 59. And that turned out to be 0.308, 308, which means it's a 30% probability, 30.8% probability that we're going to have values between 52 and 59. Okay, and the last example is G. Less than 47. So what's the probability that X is less than 47? So we'll draw a vertical line at 47, which is going to be to the left of 50. And so we have right here. So the red area is this, less than 47. So this is 47. So again, we have to use subtraction. So the blue area is going to be everything to the left of the median, the mean. And the green area will be between 47 and 50. So in this case, our red area is equal to our blue area minus our green area. But our blue area, we don't have to use any calculations because that is 0.5, because it's going to be everything to the left of there, so you get 0.5. The green area is a function of the z-score associated with this 47. So we're going to take 47 minus 50 divided by standard deviation. So our z-score is -3 divided by 4.8, which is -0.63. But we use the positive value of z to find the area we're looking for because it's symmetric. So we go to the table, 0.63, 0.236, 0.236. So our red area, which is what we're looking for, it's this little bit to here, is going to be our blue area, which is 0.5. That's everything that's to the left of the mean. And then we're going to subtract the green area, which is from here to 47. That's 0. I'm going to use green, not red. Is 0.236. So you do that subtraction, and so 0.5 minus 0.236 is going to be 0.264. So the probability of getting x less than 47 is 0.264, or 26.4% chance. So those are pretty much all the possibilities you can have. As I said, I'm going to change these numbers slightly, but they'll be the same procedure. You just have to look up different values in the tables and not just copy what I'm doing down.